In the bitter winter of 1943, along Italy's mountainous terrain, American infantrymen crouched behind shattered stone walls clutching their SCR-536 radios, the handy-talkies that commanders had promised would revolutionize communication. But as mortars thundered and wind tore through the ridgelines, the sets crackled with static, cutting off messages before they reached beyond 200 yards. The enemy could coordinate freely, while American platoons fought in isolation, each trapped in a pocket of silence. What began as a technological triumph had turned into a deadly flaw. Soldiers joked grimly that you could only reach headquarters if you shouted loud enough. Far from the front lines, in a dim laboratory at the Galvin Manufacturing Corporation, soon to be known as Motorola, a 32-year-old radio engineer named Daniel Edward Noble refused to accept that failure as inevitable. Born in Naugatuck, Connecticut, and educated in electrical engineering, Noble possessed a rare mix of discipline and audacity. The Army Signal Corps had declared frequency modulation, or FM, too unstable for field use, insisting that amplitude modulation systems were standard doctrine. Yet Noble had already seen FM's potential during his university experiments. Unlike AM, which distorted under interference, FM produced clarity through chaos, precisely what soldiers needed in battle. In defiance of official orders, Noble began modifying existing field radios after hours, scavenging parts from warehouse shelves and civilian transmitters. His colleagues called it the Midnight Project, aware that if the Army discovered it, the entire department could be shut down. He adjusted vacuum tubes, rewired circuits, and altered coils until his prototype began transmitting crystal-clear signals at ranges beyond anything ever measured. The tests reached nearly 3 miles across rough ground, through dense foliage, and around stone obstacles. In laboratory silence, the first unauthorized FM battlefield radio had come alive. But while Noble was breaking barriers in theory, soldiers were dying in practice. Each failed transmission meant reinforcements delayed, artillery misdirected, or wounded men left behind. He knew his unapproved design was not just an engineering gamble, it was a moral one. In a war where bureaucracy often lagged behind bloodshed, Noble decided that regulations would no longer dictate survival. His frequency hack had worked, but now he needed to convince an army that didn't want to listen. At the Signal Corps laboratories in Fort Monmouth, New Jersey, Daniel Noble's proposal to replace the standard SCR-536 with a frequency-modulated model was met with polite disbelief. Senior engineers insisted that FM was impractical, too sensitive for the damp, dusty, and unstable field conditions of war. Yet Noble's tests at Galvin Manufacturing had already proven otherwise. He had demonstrated reliable communication at 3 miles, 10 times the range of the current handy-talkie, and with far greater resistance to static interference from gunfire, power lines, or enemy jammers. The Signal Corps dismissed his data as theoretical noise, ordering him to cease development and focus on improving the approved AM circuitry. Instead, he ignored the directive and doubled his efforts, constructing what would become the SCR-300, an entirely new generation of portable battlefield radio. Working in secrecy, Noble and a small team of technicians stripped away unnecessary components, replaced fragile glass tubes with rugged miniature types, and reconfigured the unit's frequency stability using quartz crystal control. The device weighed just under 35 pounds, designed to fit into a backpack frame that a single soldier could carry without exhausting himself. Late one night in mid-1943, Noble initiated his first long-range test across the Illinois countryside. 2 engineers hiked out into the fields, radio strapped to their backs, as storm clouds gathered overhead. Static hissed for a moment, then a clear voice cut through. "Receiving you, strong and steady." It was the first time in military history that an infantryman could talk to command across miles of broken terrain without a wire or relay station. Despite the stunning results, Noble's achievement placed him in direct violation of Army protocol. His radio operated on unauthorized frequencies outside the prescribed AM communication bands. If discovered, both his project and his career would end immediately. He decided to gamble everything on demonstration. In late August 1943, he smuggled a prototype into a scheduled Signal Corps field test under the guise of a performance evaluation. When the official AM sets failed to maintain contact beyond a quarter mile, Noble's FM transmitter cut through wind, terrain, and artillery fire with flawless clarity. Observers, stunned into silence, watched the meter needles dance in perfect synchronization. Within days, an emergency meeting was called in Washington. The once dismissed engineer was suddenly at the center of the Army's most urgent communication revolution. In September 1943, as American troops advanced through Italy's Salerno beaches, the first field prototypes of Daniel Noble's SCR-300 arrived under guarded secrecy. Each unit was packed inside olive-drab crates marked experimental signal equipment, handle with care, destined for the 36th Infantry Division. Combat engineers unpacked the unfamiliar sets with skepticism, muttering about the illegal radio that no one was supposed to mention. Yet within 24 hours, those doubts dissolved beneath artillery smoke and gunfire. When company commanders switched them on, the difference was immediate. Clear, powerful voices cutting through the chaos like lifelines. Orders that once took runners 20 minutes to deliver now traveled in seconds. The radio's 3-mile range proved decisive in terrain that had previously swallowed every AM signal. Hills, stone villages, and rain-soaked olive groves no longer blocked communication. Platoons that once fought in isolation could now coordinate flanking maneuvers, request artillery strikes, and call medics without delay. One officer later recalled that the new set made the battlefield smaller and the Army larger. For the first time, the infantry's voice could reach artillery and air support without relay stations or cumbersome field telephones. Soldiers began calling the backpack set the walkie-talkie, though it bore little resemblance to the fragile handy-talkies of 1942. Field reports arrived at Fort Monmouth within weeks, filled with astonishment. A Signal Corps major wrote that interference from nearby explosions, once disastrous to AM systems, barely affected FM transmission. The new set functioned flawlessly, even during electrical storms and tank fire. Infantrymen dragged the SCR-300 through mud, across rivers and over rubble. It continued to operate after impacts that would have destroyed standard equipment. The Army began to realize that what had started as Noble E's unauthorized experiment had evolved into the most reliable tactical communication device of the war. But success brought risk. Official acknowledgement meant exposure, and exposure meant punishment for insubordination. Noble's superiors struggled to explain how an unapproved design had reached combat units, fearing political backlash. Yet the battlefield results were undeniable. The Signal Corps' internal memoranda shifted from skepticism to urgency, labeling the SCR-300 essential for immediate mass production. Within months, assembly lines at Galvin Manufacturing were retooled for wartime output. Against all expectation, the once illegal frequency hack had become the U.S. Army's most vital voice across the front lines. By early 1944, whispers about a mysterious backpack miracle radio had spread across Allied command posts from Naples to London. The SCR-300's combat performance in Italy had reached the ears of generals, prompting urgent inquiries into its origin. When investigators traced its design back to Daniel Edward Noble at Galvin Manufacturing, they found themselves tangled in a bureaucratic paradox. The Army had never officially approved such technology, yet battlefield reports proved its superiority beyond dispute. What began as an unsanctioned experiment had outperformed every government-funded project in development. Confronted with overwhelming evidence, the Signal Corps faced an impossible choice: punish its creator or mass-produce his invention before another campaign was lost to silence. Under intense pressure from theater commanders, production authorization arrived in February 1944 with the stamp "Top Priority, Expedite." Noble A.S. small design team suddenly became responsible for delivering thousands of units per month to the European and Pacific fronts. Chicago's Galvin Manufacturing plant, better known for producing Motorola car radios, transformed overnight into a wartime communications hub. Women technicians calibrated vacuum tubes by hand, while machinists worked double shifts to assemble the radio's distinctive steel chassis. Each completed SCR-300 was subjected to vibration, temperature, and moisture tests before shipment, standards unheard of in earlier Signal Corps contracts. The result was a device capable of operating in Arctic cold, jungle humidity, or desert heat without distortion. As Allied armies prepared for Operation Overlord, FM communication offered a strategic revolution. Infantry units using the SCR-300 could now coordinate with tank divisions, artillery, and air reconnaissance simultaneously. During training exercises on the English coast, officers were astonished to hear crisp, uninterrupted transmissions across multiple ridgelines, a scenario previously impossible under AM frequencies. In one demonstration before Eisenhower's staff, a forward observer on a distant hill relayed coordinates directly to a naval gunfire officer aboard a destroyer anchored offshore. The signal remained perfectly clear, despite fog, distance, and mechanical interference. Eisenhower's communications advisors immediately classified the radio as mission-critical equipment for all invasion forces. By the spring of 1944, Noble's illegal design had become the silent backbone of Allied communication. Yet while commanders celebrated its range and clarity, few knew the full story of how it existed at all, a story born not in laboratories, but in quiet defiance of orders. On the morning of June 6, 1944, as gray surf crashed against the bloodied sand of Omaha Beach, a young radio man named Private James Kellogg crouched behind a wrecked landing craft, gripping his SCR-300 with trembling hands. His voice, transmitted through the chaos, reached an artillery battery 3 miles inland, directing fire that shattered a German machine gun nest, pinning down his platoon. Without Noble's frequency-hopping design, that signal would have died in the static, drowned beneath the roar of battle. Instead, it pierced through steel, smoke, and terror, saving dozens of men in a single transmission. Across the invasion beaches that day, thousands of soldiers depended on that same signal strength to stay alive. By evening, field reports confirmed that units equipped with the SCR-300 maintained communication even when separated by bombed roads and scattered paratroop landings. For the first time, infantry and armor moved as one coherent machine, guided not by flares or runners but by invisible waves of frequency-modulated sound. Veteran operators marveled at the clarity of Noble's radio. No shrieking feedback, no interference, only human voices carried through the fog of war. Commanders quickly recognized that this technology had altered battlefield rhythm itself, transforming confusion into coordination. In the hedgerows of Normandy, where thick walls of earth and foliage devoured sound, the SCR-300 became an unseen ally. Lieutenant Harold Meyer, trapped with half his men under heavy mortar fire, called for air support directly from his foxhole. Within minutes, P-47 Thunderbolts screamed overhead, guided by precise radio relays that were once deemed impossible under frontline conditions. Meyer later recalled that his radio sounded like home because for the first time he could hear familiar voices beyond the smoke. As the Allied advance pushed through France, Germany, and the Low Countries, soldiers began personalizing their SCR-300s with names, symbols, and carved initials. It was no longer just equipment. It was lifeline, reassurance, and companion. Many swore they could feel its faint vibration when incoming artillery approached, as if the device itself anticipated danger. Each transmission was a thread of survival, woven into the larger tapestry of victory. And while generals issued orders through polished command sets, it was Noble's forbidden invention, carried on weary backs through mud and ruin, that truly gave the front its voice. Daniel Noble's brilliance lay not only in invention but in defiance of accepted science. During the early war years, American military doctrine insisted that amplitude modulation, AM, was the only reliable system for field communication. It was simple, inexpensive, and already integrated across countless SCR-536 handy-talkies. Yet AM signals fractured easily, scattering under humidity, metallic interference, or terrain. Soldiers described the noise as static snow, drowning words into meaningless hiss whenever a storm rolled across the front. To challenge that standard was, in official terms, insubordination. But Noble, working after hours in Motorola's Illinois workshop, discovered that frequency modulation could resist those distortions through phase stability rather than amplitude strength, creating an entirely different form of clarity. He realized that FM's consistent wavelength, though initially energy-hungry, maintained coherence across varied atmospheric pressures and metallic surroundings. His team hand-built early prototypes, each solder joint done under secrecy, concealing their work from visiting inspectors who would have confiscated the circuits. Noble tested his first functional transmitter by bouncing signals through Chicago's industrial corridor, where steel structures simulated the echoing distortion of European combat zones. The results stunned even his skeptical colleagues: crisp audio across multiple miles, unaided by relay towers or external amplification. When presented to Army Signal Corps evaluators in 1943, the reaction was skeptical, even hostile. One officer reportedly accused Noble of technical misconduct for modifying government frequency allocations without authorization. But his demonstration silenced the room. Static-free communication at 3 miles, even through reinforced walls, forced immediate reconsideration of wartime radio priorities. The project, formerly dismissed as impractical, was reclassified urgent, and by autumn, the SCR-300 entered accelerated production under Motorola supervision, becoming the world's first portable FM transceiver designed for tactical use. Inside the device, its curved chassis reduced resonance, while nickel-coated shielding dampened frequency bleed. A 12-tube configuration balanced power draw with clarity, while its antenna array adjusted automatically for terrain reflection. The entire system weighed 35 pounds, heavy for infantrymen but revolutionary compared to field telegraphs or truck-mounted transmitters. By merging electronic discipline with battlefield pragmatism, Noble had engineered something far more profound than improved radio. He had created the technological language of mobility. His defiance transformed invisible energy into tactical synchronization, ensuring that, from Normandy to the Ardennes, every whispered command could still find its way through the smoke. The SCR-300's true test came not in laboratories, but amid chaos and smoke on the European front. In June 1944, as the first waves of Allied troops stormed Normandy's beaches, the newly issued radios hummed within waterproofed satchels strapped to the backs of young infantrymen. At Omaha, communications had always been the battlefield's weak point. Orders delayed, artillery called on outdated coordinates, air cover arriving too late. But now, with a flick of a switch, platoon leaders spoke clearly to command posts miles away, their words cutting through static like light through fog. Reports describe entire companies coordinating in real time, redirecting fire, requesting engineers, and guiding tanks through minefields with precision previously impossible under AM systems. When the 101st Airborne advanced into Carentan, operators used the SCR-300 to relay enemy armor sightings directly to Sherman tank units, enabling cross-branch coordination unheard of before. The field commanders noted that, for the first time, tactical momentum no longer collapsed when wired networks were destroyed. Even under mortar bombardments, messages moved fluidly through terrain that once silenced communication entirely. The signal strength held firm through rain and ruined infrastructure, granting the Allies an invisible advantage across the shattered French countryside. By late 1944, more than 50,000 SCR-300 sets operated across Europe, each one a lifeline, connecting frontline chaos to distant command. German intelligence reports began documenting unusually fast coordination among American units, mistaking it for superior reconnaissance rather than technological transformation. Axis operators attempted to jam the new frequencies, yet FM's narrowband structure resisted interference, leaving enemy attempts futile. The radios survived mud, freezing temperatures, and near-constant shell fire, earning the nickname, the talker that never dies. In the Ardennes offensive that December, when blizzards crippled both visibility and logistics, Noble's design again proved decisive. Infantrymen trapped in snow-covered forests used their SCR-300s to call artillery within seconds, halting advancing panzer divisions that otherwise would have broken through Allied lines. The radio AS durability under these conditions cemented its legacy not just as a tool, but as an equalizer, a bridge between chaos and coordination. Every clear signal that winter echoed Daniel Noble's defiance, his illegal idea now saving thousands who never knew his name. By early 1945, Allied command recognized that the SCR-300 had reshaped warfare as profoundly as radar or code-breaking. Reports from field officers credited the backpack radio with reducing casualty rates by nearly 30%, citing faster evacuation calls and precise artillery responses. What once required runners braving open fields or vulnerable telephone lines could now be accomplished in seconds by a soldier kneeling behind a hedgerow. The very rhythm of combat had changed, as information flowed like electricity through the veins of the Allied advance. What began as an illegal experiment now pulsed through every major offensive from the Rhine to the Ruhr. In war rooms from London to Washington, military planners began realizing that this portable FM network was not merely tactical, it was structural. Commanders could now coordinate multiple divisions across unpredictable terrain without dependence on fragile wired communication. The radio's stability against interference allowed simultaneous transmissions, creating what historians later called the first real-time battlefield network. Daniel Noble's forbidden circuit, once dismissed as engineering arrogance, had created the backbone of modern command and control systems. Soldiers who carried it often had no idea that its range and clarity came from principles their own regulations had banned just years before. The U.S. Signal Corps, once skeptical, transformed into Noble's strongest advocate, commissioning expanded production runs even before the war ended. Laboratories at Fort Monmouth reverse-engineered his prototypes to standardize future field sets, while Bell Laboratories engineers began integrating frequency modulation into post-war civilian designs. By the time Germany surrendered, nearly 100,000 SCR-300s had been built, each one a living testament to what rule-breaking ingenuity could achieve under pressure. On the ground, its legacy grew with every transmission that reached its destination. Infantrymen in the Philippines used it to coordinate amphibious landings under fire. Paratroopers in Holland relied on it to guide drops through fog and darkness. Engineers in Italy used it to summon bulldozers when bridges collapsed under tank weight. Wherever the human voice could carry over 3 miles of battlefield ruin, the SCR-300 stood between victory and silence. What had once been a single, unauthorized frequency now connected half the free world, proving that sometimes the most radical innovations are born not from authority, but from defiance. When the war ended in August 1945, Daniel Edward Noble was summoned to Washington, not to receive a medal, but to explain his unauthorized modifications. The Signal Corps bureaucracy, wary of precedent, viewed his defiance as dangerous, even if it had saved lives. In a small War Department office surrounded by officers in starched uniforms, Noble stood quietly while reports of the SCR-300's battlefield performance filled the table before him. General Matthew Ridgway himself had sent a letter praising the radio's reliability during the Normandy breakout, writing that, "Without this device, our lines would have drowned in static." Yet the same innovation that brought clarity to the front lines now generated confusion in the corridors of power. For weeks, committees debated whether his FM network violated procurement rules. Some argued that his redesign ignored testing protocols, while others noted that his frequency modulation eliminated deadly interference from artillery bursts and atmospheric noise. In the end, the truth spoke louder than regulation. Testimony from frontline officers confirmed that Noble's illegal frequency hack had shortened engagements, reduced friendly fire incidents, and restored coordination between infantry and armor units that had been lost since 1940. Quietly, the Army decided to rewrite its communication standards rather than punish the man who had outpaced them. In late 1946, Noble was invited to join Motorola, where his wartime breakthroughs laid the foundation for commercial FM and early mobile telephony. He would later oversee research that produced the first transistor radios and two-way portable sets for emergency services. His transition from secret military innovator to corporate engineer symbolized a broader shift in post-war America, where battlefield necessity merged with civilian technology to shape a new era of connectivity. Still, among surviving soldiers, recognition spread more simply. Veterans spoke of the pack that never failed, the radio that turned chaos into command. In memoirs and unit histories, operators recalled the reassuring hiss of FM clarity under shellfire, the moment they realized someone, miles away, could hear them. Daniel Noble never sought fame, but his defiance rewired the sound of war. Long before digital networks or satellite uplinks, his signal carried through mud, smoke, and fear, teaching the modern world that every revolution in technology begins with one person willing to break the rules. In the decades that followed, Daniel Edward Noble's creation faded quietly into museum displays and technical archives, yet its pulse continued beneath every new communication breakthrough. The SCR-300, born from defiance, became the seed from which all modern mobile radios, cellular systems, and digital battlefield networks would grow. By 1955, U.S. Army field manuals still referenced his original circuitry, while engineers developing early space communication relays cited his frequency stabilization methods as foundational principles. Every transmission that cut through static, from police dispatchers to astronauts orbiting Earth, carried a trace of his forbidden frequency. Historians now view the SCR-300 as the turning point where human communication transcended distance and terrain, transforming warfare into a coordinated, responsive science. It was not forged by committee or polished in laboratories, but by one man willing to violate orders for the sake of clarity. In a world suffocated by regulation, Noble had proven that progress thrives where curiosity outpaces permission. His illegal act reshaped military doctrine, forced the U.S. Army to adopt FM as a standard, and permanently retired the unreliable AM systems that had cost so many soldiers their lives. By the time of his retirement in the late 1960s, Noble rarely spoke of the war or the controversy surrounding his invention. When asked about his motivation, he reportedly replied, "I didn't build it to be right. I built it so no one would die waiting to be heard." That single sentence encapsulated the quiet morality behind his defiance, a conviction that technology must serve life, not rules. His work ultimately bridged the gap between military necessity and human survival, proving that innovation's truest measure lies not in patents, but in lives preserved. Today, 80 years after his unauthorized experiment, Daniel Noble's spirit endures in every encrypted radio, every soldier's headset, every whisper transmitted across impossible distances. His was not a victory of noise, but of understanding, a triumph that turned silence into strength. The static that once defined battlefields gave way to connection, and through one man's illegal frequency, the modern age of communication was born, carried forever on the unseen waves he dared to bend toward hope.